All right, Biology 11, continuing our evolution unit. Our next talk is on selection pressure. Now, I know on your D2L notes, selection pressure and speciation go together. I'm going to break them up. We're going to do selection pressure today. Speciation we will do tomorrow. I just put them there because I had made them on the same day and posted them back when I originally made this PowerPoint. Speaking of PowerPoints, up in the top corner, of course, is your note that you have from your D2L website for the class. And then, of course, I've got different little diagrams or things that I can put here. So let's talk about how to become Mother Nature's favorite today. All right. So it's all about pick me, right? Now, right now, our understanding is that the direction of evolution, so why things change and start growing, longer wings or shorter legs or, longer claws, whatever it happens to be, or changing their coloration from this to that. It's a complex interaction of genetics. Obviously, your genes dictate your traits, so what you're going to look like, and your abilities from those physical characteristics, that's genetic, a great deal of it. Then you throw in a little bit of mutation. These are changes, silent, good, and bad. We talked about those last day. Throw in the odd good mutation, hopefully no bad ones. And that can change things up, change your traits, changes your abilities, changes your ability to survive. And then, of course, environmental pressures. We know Mother Nature has her checklist, right? And that checklist has a variety of things, a whole bunch of things. Some you probably would be well aware that's on there. Other things you might not think would be a challenge for creatures out in the wild every day, right? So genetics is the source of variation, right? When we look at a population, a group of the same species in an area, we see a whole bunch of variety, variation and varieties of, if we're talking about fur color, feather color, leg length, strength, size, right? All of these things. So genetics is a source of the variation within the population for a given trait, right? But make no mistake, it's the environment. Mother Nature is the one that's going to determine whether your genetics and the traits that come from them are going to be, good, if you'll be one of the chosen ones, if you'll survive, and if you'll survive long enough to mate and have little offspring that have these same traits. So that's the thing. The variation comes from genetics, but the chosen variation, the reason why we see these ones rather than these ones prevalent in the population is because of nature. Nature does the selecting, natural selection, right? So selection is the pressure that exists against everybody that's trying to live in an area, right? Whether it's the ocean, the forest, the mountains, whatever. So Mother Nature has her checklist, and I actually managed to steal one of her checklists. So here's one here that might be for maybe a forest creature. So here's Mother Nature. Do not tell her I took this. She is very cold. She will be very unrelenting and not too forgiving if she finds out I have this. So catching food. Well, there's a first option for food, and if that's not there, can I get my second? Can I get my third? Or if I live in an environment where there's only one option, then I better be able to get it. Finding water. Not just finding water. Is the water clean? What's the salt level like in the water? Because some creatures can handle some salt, some can't. What's the pH like of the water? Right? I can survive with a certain pH of water. If it gets too acidic or too basic, I'm toast. I got to move or die in that area. Can I escape predators? Always a big one. I don't want to be a meal for someone else. Finding a mate, right? Survive, not only survive, but pass on those traits to the next generation. So hopefully I'm pretty enough to attract a mate. Coloration. Coloration helps me with the hiding from the predators, but it can also help me catch food. If I'm a similar color to my background, whether it be the prairies, rocks, water, whatever it is, if I can blend in with my environment pretty good, I can sneak up closer to prey before I spring my attack, right? So coloration just isn't for escape. It can also be, it can help me with the hunt. Eyesight, seeing predators or seeing prey from a good distance away and then planning my route of attack or escape. Always good to have speed and agility, whether it's speed in running and escaping or catching, or speed in digging, or speed in swimming, or speed in whatever. It's always good to have these. I hope I'm fast enough to live where I'm living. Speaking of that, I've got to find a place to live, right? I've got to get my own little piece of the pie out there, right? So I've got to be able to find a place to live. And if someone else is living there, I might have to bump them out. So I hope I'm strong enough to do that. Temperature. Even though it's late April right now and it's supposed to be nice and warm, it isn't. Mother Nature's decided to throw a little bit of a curveball at us. It's been pretty cold as far as Aprils go. So temperature. Some places are going to say, hey, you better be able to handle the heat. Others are going to say, it's freezing here. You better be able to cope. Immunity. The water that I'm drinking, it is not filtered. It's just from a pond or a spring or a puddle, whatever it happens to be. So there's different immunity levels within my population. I hope I have a good one, right? If I get a cut, I hope my immune system can deal with the bacteria that might get in there, right? No Band-Aids, no iodine, no antibiotics for me. I'm a wild creature, right? And hearing, of course. And then there's even more pages of things. So Mother Nature's checklist has a ton of things on it. And again, every day she has this checklist. Now, we talked about environmental change being relatively slow, right? More often than not, change is very gradual. So this list would be the same day after day after day. So if I went through this list and was like, check, 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 I had a whole bunch of check marks, life is pretty easy in this environment. I'm going to stay here, right? The more X's I get, well, check that, X, X, X. If I get a bunch of X's, I have two options. I either have to go somewhere where I'm going to have more check marks, or I'm going to die in this area, right? So quite often creatures will try to leave. Now, not every time do you have the option to leave. If you think about a large lake, a landlocked lake, if I'm a fish in there and something changes, perhaps salinity or pH of the lake, and I can't cope with that, I can't go anywhere else. I'm a fish. I have to stay in the water. If the lake is landlocked, I could be a goner. I could be dead, right? And that could lead to a localized extinction of my species in that lake. So again, this is selection pressure. Having to be able to do all of this stuff every single day, right? Mother Nature is a grind. Anyway, I'm going to go hide this because if she sees me, she'll kill me. I will be deselected. So let's talk. There's different types of selection pressure. All right. The first one is stabilizing. All right. With stabilizing selection pressure, well, it is what it sounds like. The environment, Mother Nature, is stable. So day after day after day, the conditions are the same, right? So nothing is really changing here. So if I was a good survivor the first day, I should be the second day, the day after that, the day after that. If I'm getting lots of check marks on that list, right? There's no change. So if life is good for me, it stays good for me. If life is bad for me, it's going to stay bad. Things are not changing. It is what it is, right? Now, what happens here is you still have all of these offspring, right? We talked about Darwin noticing that tons and tons of offspring are born all the time, right? So here's the thing. We have all these offspring, and they're trying to get a foothold in my area as well, in my habitat, right? My ecosystem. And so there's a lot of intraspecific competition, right? Intraspecific means not competition with another species. It means competition from within my own species, my own population. So way too many offspring are born than what can survive, but they're still going to challenge for a lot of the things on that checklist that I just showed you, right? So here's the thing. what happens to a population that undergoes stabilizing selection? Well, it actually gets sharper and more honed. Those traits that allowed us to survive become even more augmented, right? Think of our cheetahs from an earlier lecture. The cheetahs get faster and faster and faster. And once all the cheetahs have the longer legs, that was one of the differences in that lecture, the longer legs, and now everybody has it. Now we're looking for that next sharper, keen little edge that's going to, help propel me above all the others. So it kind of focuses that population and makes competition levels really, really high. Everybody in the population, though, tends to be pretty good at surviving. So competition level is pretty high. So what we're going to deal with, or the example we're going to use, are hummingbird beak and tongue lengths in comparison to flowers, right? So let's take a look at this. Hummingbirds. So the beak and tongue length. Sorry for the sloppy penmanship. We find often in nature with hummingbirds, the beak and tongue length is very similar to the flower length. Hummingbirds feed on nectar, which is made at the base of the flower, right? So what we see are that the beaks of these hummingbirds, they're the same length as a flower, so they can still feed, but the beaks aren't too big and bulky and make it cumbersome to fly, right? And it also adds extra weight, which means they need even more energy. So the ideal beak for hummingbirds is one that matches the flower length perfectly. I can still feed, my beak is long enough, but it's not too long where it makes it cumbersome and hard to survive. So in stabilizing selection, the flowers stay the same size, right? Year after year after year, season after season, right? And so what happens is, and I'll show you in this graph, the longer beaks start to disappear. This is our trait here. So we've got shorter beaks here, longer beaks here, and then the medium-sized beaks here. So let's say we had medium-sized flowers. Well, that works against the longer beaked birds. Yeah, they can still feed. They've got an extra long beak, but they need a lot more energy to carry that heavy thing around, and it makes them more cumbersome it makes it more awkward to fly and escape from predators in that. They might be more easily caught. Maybe they can't fly as fast because of the extra weight. Agility would also be lost, right? The shorter beaked birds, well, that's an obvious problem. If the flower is 10 centimeters and my beak is only 5, I'm not going to be able to feed, right? And if you can't eat, well, that's it doesn't take much of a brain to tell. That's a pretty big problem. So that's stabilizing selection. Environment stays the same, no changes over a long period of time. Mother Nature's checklist is unchanged. What we see is competition within that species that heightens, and we see the extreme forms of the trait, the shorter and the longer beaks in this case, being selected against, and the current population norm being selected for, which is the medium-sized beak in our example. The next type of selection pressure is directional selection. Directional selection is when the environment changes. Now, the environment, it could be one small thing. So we were just talking about hummingbird beaks and flowers, right? It could be a change in the average flower length. And everything else stays the same. Water stays the same. Soil content stays the same. Air temperature stays the same. Predators are the same. My coloration of feathers is the same. Everything is the same. The environment changed one little thing. Flower length, right? So that little change in the environment shifts the population one way or the other. So if we have medium beaks to meet up and match up with medium flowers, what that means is that perhaps people take over the area and add fertilizer to the ground. And that fertilizer makes the flowers grow. And the flowers grow longer. And so what we will see is now the medium beak birds are struggling more and more to survive. And that odd, every once in a while I'm going to come across that long beak bird. It's now going to thrive. Or if we go the opposite, right? This is something man also does. They dump waste into the soil or to the ground. Now the flowers are getting smaller. Well, the short beak birds, if there are any left, or any just happen to be scraping by, now they're thriving because they can eat. They couldn't eat before too well. Now they're eating very well, and they're the ones that need less energy, and they're the fastest, most agile. They can get away from predators even quicker. All right? So now we'll see a population shift to one extreme or the other. So again, if this was our beaks, right, and this was medium, this was long, and this was short, a change in the overall length of the flowers, we'll see this become this. If the flowers got longer, our population becomes this. Beaks stop being medium and they start shifting towards medium and longer, right? The same way, if there was something in the soil that happened to work against flower length and the flowers got shorter, we would see this sort of a shift. So whether you're going towards the large end of things or the other end, the short, the one extreme form of the trait or the other will be selected for, not both at the same time. So that means you either have this happening where flowers are getting longer, or you have that happening where the environment throws a curveball of shorter flowers. All right? So it's this or that. It's not both. All right? Don't be confused and think we're doing both. No, that's the next thing. All right? So selection pressure is one way. You're going towards this extreme form of the trait or the other one, not both. All right? So a change in length of flowers, we'll see a change in length of the hummingbird's beak. Another good example, salmon populations. They started using gill nets out in BC, right? And what gill net does is if you're too big, you get caught in the net. And so the adult salmon would be going through the rivers and that, trying to get out to the ocean or coming back, and they would catch them, right? And so the larger salmon, the larger adults were getting caught in the gill nets, but the smaller ones were able to still get through the meshwork of the net, right? The net would have this kind of pattern here like this, and if you were a big adult, you were getting caught in it, but if you were a smaller one, you could get through that hole. And so what they saw was kind of this situation. We had our medium-sized salmon. The larger ones and the medium ones were getting caught in the net, but these smaller ones were able to survive and then mate and have offspring. And their offspring would be smaller just like them because size is genetic to an extent, yes? So it was directional from medium salmon to smaller salmon, all right? So that's just another example that I provided here in the note. Here's a diagram much nicer than mine. So here again, this was our previous population, and then there's a change, right? Or sorry, our dotted line was our previous population, and there's a change. And we see the population shifting in one direction or the other. So just think about that. One direction or the other for directional. You're not going two different ways. Going two different ways is actually the next one, disruptive. I'm going to keep this. So with disruptive selection, what we see is that the environment, again, it changes, right? This is not stabilizing selection. So there's a change. And what it does, the environment now selects for the two extreme forms of the trait. So again, if this is our hummingbird beak lengths, the medium beak was great for the medium flowers at first. But now what has happened is those medium flowers have been pulled up. Something has happened. Maybe people have come in and turned the field into a park and they started planting flowers. And now there is short flowers planted in the park, and there's also long flowers planted in the park. So in our previous population, if we look, all in this area, these are all medium beaks. There were a few short, right, beaks out there. Not a whole lot, and a few long, very few, right? Hardly any. You can see the greatest numbers are in here. But now humans come in, they get rid of those flowers because they see them as, I don't know, unsightly or unattractive, whatever. They put in these flowers. And what happens is we see a shift in two directions at once. All right? So what we see is the short beak ones can now thrive. And so we'll see a shift in this direction. Shorter flowers means the short beak birds can thrive. They're great at escaping predators. Their numbers go up. So short is going to have some positive growth. At the same time, the long ones who were just getting by before, those long flowers, see a shift in this direction. And now the long bird beaks also have positive growth within their population. Their numbers go up. All the pressure now is against these guys. So Mother Nature's coming down on the mediums, very, very difficult. All right? This is selection pressure coming down on them. All right? So when we see this separation and the favoriting, if that's even a word, but the favoriting or the selecting of the two extreme forms of the trait, that's disruptive selection. That middle ground, what happens after a while is that middle ground starts to disappear. And we end up with a population that has very, very little middle ground. Very tough on the mediums. They couldn't feed from these flowers to get now competed by the faster, more agile birds for these ones. Used to be good days for the mediums, and now it's very, very difficult. So their numbers go down. All right? So again, this is just explaining long or short flowers replace the medium flowers, and we see the population shift, right? Disruptive selection can lead to speciation. Now, what speciation is when your original population undergoes a change, so there's an environmental change, and we see the shifting in the population, disruptive selection, and now we've got two populations. And what happens is if they become different enough from each other, they may stop freely interbreeding. They may stop recognizing each other. So what we may see as a result of disruptive selection is speciation. I'll try to fit it in here neatly. Speciation means the middle ground there's so little middle ground here. That's like the bridge between the two populations that it's almost non-existent. And the short beak guys, they all hang out with each other, and the long beak guys, they all hang out with each other, and then after a while, because they become so different, they no longer recognize each other as part of the same species, so they stop freely interbreeding. Well, to be part of the same species, I have to be physically similar, freely interbreed, and produce offspring that can have offspring themselves someday, right? Viable offspring, we called it. If these guys are no longer, if the short beaks and the long beaks are no longer freely interbreeding, and they're only breeding within the short beaks and long beaks are only breeding with other long beaks, they've just speciated. They form two species. And we see this in birds. There are bird species out there called the long-beaked that, the short-beaked that. They made reference to it in in Darwin's Dangerous Idea. They were talking about birds in the Amazon basin in the rainforest that migrated up the hills into the mountains. They talked about some of the differences that they would have to live in the mountains versus the Amazon forest. Now, if you brought the two birds together, would they still recognize each other? And if the answer is no, then they're not going to breed. That's speciation, even though they were at one point one population, right? So on our tree of life, on Darwin's tree of life, whenever this occurs, speciation, you can have a branching. One species, ancestral species, becomes two, right? Disruptive selection can play a key role in that occurring, all right? So there's a picture of it there. I drew one here, but you can see one there. The black dotted line was our previous population, but that norm, that medium beak that was good for all those years, wasn't good anymore. So Mother Nature comes down hard on it. And we see the short and the long beaks, the two extreme forms of the trait, being favored, and of course, that can lead to speciation. Our last one is sexual selection. Now, sexual selection is a little different than those other three. So far we've had stabilizing, disruptive, and directional. This one's a little bit different. Those other ones were all about fitting to the environment and fitting to, you know, surviving. This one is about finding a mate, attracting a mate, and reproducing with the mate to produce, you know, to help contribute to the next round of the population, the next generation. So this is where traits that are favored by the opposite sex are selected. It's not the environment. I guess the creature, you know, the opposite sex, the females are in the environment, and quite often, fellas, I hate to say it, it's the females that do the picking here. When it comes to sexual selection, the selection is done by the females almost all the time, all right? So the females, there's certain traits, and we've seen this before. You've probably seen it and didn't realize it was called sexual selection, but you see birds with certain dances, or they'll puff up their feathers and show off their feathers. Look at how bright and amazing my feathers are. Look at my intricate dance. Or they'll do calls. Listen to me sing. Oh, ain't I amazing? You should mate with me and we'll produce offspring for the next generation. That's what they're doing, right? So what we often see with things that undergo sexual selection, we'll see sexual dimorphism, all right? These are related but not the same. Morph is shape, right? And of course, di is two. Think of the mallard duck. If I said, okay, think of a mallard duck, you're probably thinking of a duck with a brown body and that metallic green head. That's actually the male. The female is just a little brown duck. Female mallards don't have the green heads. Only the males do. That's sexual dimorphism. It's not necessarily shape. They both look like ducks. But the male form and the female form look different. You can easily tell them apart. Peacocks are the same way. When you see a peacock with all those bright blue and green and, you know, all these different crazy colors of feathers, that's the males. The females don't have that. The females are just little brown birds, right? So why do the males have these bright colors or the ability to do these dances or the ability to make a certain call? It's to attract the females. And she picks who she's going to mate with. So lines are another example, actually, right? A female line and a male line, you've got the male is larger and has the mane. The females don't have the mane. They tend to be smaller in terms of body size. That's sexual dimorphism, right? And lions undergo sexual selection as well. Only it's not as nice. It's not listen to me sing, watch me dance, look at my beautiful feathers. It's I'm going to kill the other guy and take over. That's one of the things Disney actually got right in that movie. But a lot of the stuff was wrong as well. So behaviors and abilities like fighting, singing, dancing, they're all a source of sexual selection. So of course, this does go back to your genetics. Your size and strength, that's genetic, right? There's genes for musculature and strength, right? Your ability to sing, your vocal cords and their construction, that's genetic. The bright feathers, that's genetic, right? So all of these things tend to be genetic, but it's not nature necessarily. It's the females are in nature, but it's not Mother Nature. It's not necessarily survival. In fact, what can happen is sometimes sexual selection works against survival. Right? Sometimes these two things work against each other. Think of those birds. If they're out there puffing up these really bright feathers that don't really blend into the environment too much, and they're out there cawing or tweeting or hooting or whatever they're doing really, really loud, yeah, it's attracting the mate. It's also attracting a lynx or an eagle or something else, a hawk that's going to grab this thing and kill it and eat it. So it's almost like it's an example of conflicting selection pressure. I want to survive. I don't want to attract predators. I want to be able to hide. But at the same time, I've got to be really flamboyant and loud to get the mate and contribute to the next round of the population. All right? So that's why it's a little bit different than the other ones. The other ones, it's all about fitting in with that environment and surviving. This one is about reproducing. And sometimes this, winning the ability to do that, works directly against that. All right? So here are some pictures here. So again, there's a peacock there. That's a male. Anytime you see one that looks like this, it's got to be the male. All right? Here we can see some grouse. So this is the male here, and he's showing off here the female grouse here, and he's got his feathers all, the air sacs near his trachea are all puffed out. His feathers are nice and big, and he's like, hey, ladies, look at me. And they're like, well, they actually don't look too impressed. There's a couple of them just looking away, right? And of course, sometimes it comes down to a battle, right? So the males will compete and fight each other for control of the females in the group, right? So we have some antelope fighting, and of course lions, right? Lions will come, and so what actually happens, an interesting thing with lions and hippos and some other creatures, is if this was the previous leader of the lion herd, pride, thanks Lion King. If this was the current leader of the pride and this was a new male coming in, if the new male kills the old leader of the pride, he'll also try to kill the offspring. So Disney actually got that right. I think when Scar beats up Simba, Mufasa. Sorry, Scar beats up Mufasa, kills him, and then tries to kill Simba. That's how it goes. And then Simba goes and makes friends with a pig and a meerkat, and they sing songs, which craziness in Disney movies. I don't like that. Too many songs. Movies could be 45 minutes or an hour and a half, 2 hours because of all the songs. Anyway, on another note, and then what happens is any of the young lions that escape when the new guy takes over, they go out and live on their own. They become rogue lions. And then they come back and they'll take over their own pride if they're big enough and strong enough, which is what happens in The Lion King. Anyway, that's it. So that concludes our talk on selection pressure. There will be a talk on speciation following this one. I hope everything is understandable and crystal clear. And that's it. Enjoy. If you have any comments, comment below this YouTube video in the comments section, or reach out to me through Edsby if you're one of my students. All right. Hope everything was clear. Bye-bye.